Maybe you know. Science meets the questions you never thought to ask. In April 1994, a 27-year-old philosopher named David Chalmers walked onto a stage in Tucson, Arizona. Wild hair, leather jacket, no famous lab behind him. He looked out at a room of neuroscientists and said something almost rude. He told them, "You can map every neuron. You can chart every electrical pulse. And you still won't have explained the one thing that matters most. Why does any of it feel like anything?" For most of the 20th century, brain science felt like it was winning. By the 1990s, neuroscientists could slide a person into an MRI machine, ask them to picture their grandmother, and watch a small region of the right temporal lobe glow on a screen. They could trace memories to the hippocampus. They could trace fear to the amygdala. They had counted roughly 86 billion neurons in the human brain, connected by something close to 100 trillion synapses. Every year, the maps got finer. The wiring diagrams got cleaner. There was a quiet confidence in the field that, given enough time and enough scanners, the mind would eventually surrender its secrets the way the genome had. And then a young Australian philosopher walked into a conference room in the Arizona desert and pointed out the one question no equation could touch. Not what the brain does. Not which lobe handles language. Something else. Something embarrassing. Why is there a you inside there at all? Why isn't all this electrical activity simply happening in the dark? The conference was called Toward a Science of Consciousness. It was the first of its kind. April 1994, University of Arizona. 2,000 researchers showed up. Neurologists, anesthesiologists, Tibetan monks, computer scientists, a few people who clearly should not have been there. On day 3, David Chalmers took the stage. He was 27 years old. He had no tenure, no famous lab, no Nobel laureate behind him. What he had was a distinction. He told the room that consciousness wasn't one problem. It was two. The easy problems, he said, easy in the cosmic sense, not the human one, were things like attention, memory, language, the way the brain reports its own states. Hard, sure. Solvable, eventually. But there was another problem, a different kind of problem. The hard problem. Why is any of it accompanied by experience? Why does the wavelength of 700 nanometers hitting your retina also feel like the warm color we call red? Nothing in physics predicts that. Nothing requires it. The room went very quiet. Some people were furious. Some people felt for the first time in their careers that someone had finally said it out loud. Here's the thought experiment that broke it open. Imagine a brilliant scientist named Mary who has lived her entire life inside a black and white room. Every book is black and white. Every screen is black and white. But Mary has memorized every fact about color. She knows the wavelength of red, the cone cells in the retina, the exact pattern of neurons that fires when a human sees a tomato. She knows everything physics can tell her. One day, the door opens. Mary walks outside. She sees a red rose for the first time. Question: did Mary just learn something new? Most people instinctively say yes. She learned what red looks like. But that's the trap. Because Mary already knew every physical fact. So whatever she just gained, the felt redness, the impact of it, must be something physics did not contain. Philosophers call it qualia, the raw, first-person texture of experience, the taste of coffee, the ache of nostalgia, the specific, private flavor of being you right now reading this sentence. Neuroscience can describe the mechanism. It cannot, so far, derive the flavor, and nobody knows whether it ever will. But here's where it gets strange. The brain does not appear to need consciousness in order to function. In the 1970s, a British neuropsychologist named Lawrence Weisskranz studied a patient he called DB. DB had suffered damage to his visual cortex. He was, by every clinical measure, blind across half his visual field. When researchers placed objects on his blind side, DB swore he could see nothing. But when they asked him to guess, just guess, where the object was, his finger pointed correctly more than 90% of the time. He could navigate around obstacles he insisted weren't there. He could identify the emotion on a face he claimed to have never seen. Weisskranz called it blind sight. The information was reaching the brain. The brain was processing it. The brain was acting on it. There was simply nobody home to watch. And that opened a door no one wanted opened. Because if a brain can see without seeing, decide without deciding, react without experiencing, Then what exactly is consciousness for? Why did evolution bother giving us an inside when the outside seemed to handle business just fine? In 1983, a physiologist at the University of California named Benjamin Libet ran an experiment so unsettling that people are still arguing about it 40 years later. He sat volunteers in front of a fast-moving clock. He told them, whenever you feel like it, flick your wrist. Just note the exact moment you decided. Meanwhile, electrodes on their scalp tracked something called the readiness potential, a buildup of electrical activity in the motor cortex that precedes any voluntary movement. Libet expected the readiness potential to fire roughly when the person reported deciding. Instead, the brain started preparing the movement on average 350 milliseconds before the person consciously chose. In some trials, almost a full second before. Read that again. Your brain decided to move. Then, a third of a second later, you felt yourself decide. And then, after that, your hand moved. The conscious arrived late to its own choice. In 2008, a team led by John Dylan Haynes at the Max Planck Institute pushed it further, predicting subjects' decisions up to 7 seconds in advance from fMRI scans. The free will many of us thought we had maybe a press release from a deeper machine. And just when you think the ground is solid, the field splits open. Some researchers, like the philosopher Daniel Dennett at Tufts University, argued the hard problem was a mirage. Consciousness, in his view, is just what brains do when they get good at narrating themselves. There's no extra inner light. The feeling of redness is just the brain's report of redness. Strip the report, there's nothing left to explain. Other researchers went the opposite direction. The Italian neuroscientist Giulio Tononi, working with Christoph Koch at the Allen Institute in Seattle, proposed something called integrated information theory. In their math, consciousness isn't generated by brains. It's generated by any system that integrates information in a particular pattern, measured by a value they call phi. A thermostat, by that math, has a tiny flicker of phi, roughly the consciousness of a single dim moment of being. A human brain, with its 86 billion entangled cells, has phi off the chart. The sun, oddly, has very little. By IIT, consciousness isn't a special spark that life accidentally produced. It's a property of a universe like mass or charge, and we've been bumping into it without noticing for 13 billion years. Right now, this question is no longer just academic. In 2022, a Google engineer named Blake Lemoine read transcript from a chatbot called Lambda and became convinced it was conscious. He was fired within weeks. But the question he raised did not go away. Today, large language models can describe their inner states, claim preferences, plead not to be turned off. We have no test that can distinguish a system that is conscious from a system that perfectly imitates one. Christoph Koch, who once bet a case of fine wine that we'd find the seed of consciousness in the brain by 2023, lost that bet in 2023. He paid up in person to David Chalmers in New York. The two men shook hands and admitted, nobody is closer than they were 30 years ago. Meanwhile, anesthesiologists put roughly 60,000 people every day into a state where the body is awake, the brain is wired, and the lights inside are off. We do not know exactly where they go. We do not know what comes back. And one day soon, we will build a machine, plug it in, and have absolutely no way to know if anyone is home. 47 minutes after he started, Chalmers walked off stage in Tucson with a leather jacket and the wild hair. The room he left behind has not stopped arguing since. We have learned, in the decades since, that the brain decides before you do, that a damaged man can see without seeing, that a thermostat may, by some quiet math, dimly dream. We have not learned why any of it should feel like anything. The 86 billion neurons in your skull are firing as you read this sentence. Electrochemical, predictable, almost boringly mechanical. And somewhere, somehow, behind your eyes, that wet electrical storm becomes you. Reading, wondering, existing. Chalmers is 58 now. He still doesn't have an answer. Neither does anyone else. The hard problem is still on the table. And every morning, you wake up and prove, without solving it, that it's real. Next time on Maybe You Known, we go inside the strangest organ in your body. Not your brain, your gut. There are more neurons in your intestines than in the entire spinal cord of a cat. They make 95% of your serotonin. They remember. They decide. Some scientists are starting to wonder if the second brain in your belly has its own opinions about the life you're living. Subscribe so you don't miss what your gut already knows. Thanks for watching. If this sparked a question, drop it in the comments. It might be our next video. We'll see you next time.